Darkness stretches across the universe, an endless canvas of stars, galaxies, and cosmic wonders. But somewhere far away in a distant corner of space lies a force so powerful, so strange, that it challenges everything we know about reality. Scientists call it a black hole, a cosmic monster that devours everything in its path. Even light cannot escape its pull. But what really lies inside? Today, we embark on a journey into the heart of darkness, to witness the unimaginable. The universe is vast, almost impossibly vast. Galaxies spin gracefully like cosmic dancers, stars blaze brightly in a symphony of light, and planets drift silently in the cold void. Yet hidden among this beauty there exists something far more mysterious, something invisible yet deadly. A black hole. It is both creation and destruction, a paradox that has fascinated scientists, philosophers, and dreamers for decades. To the untrained eye, a black hole is simply a dark spot in space. But appearances are deceiving. Surrounding it, a glowing disk of gas, dust, and cosmic debris swirls at unimaginable speeds. This is the accretion disk, a fiery halo of matter spiraling toward oblivion. The gravity here is extreme. Light itself bends and twists, stars appear distorted, and time seems to slow down. Anything that comes too close is doomed, pulled relentlessly toward the event horizon, the invisible boundary beyond which there is no return. Imagine standing at the edge of a black hole. The cosmos stretches infinitely around you. Stars shimmer, galaxies spiral, and yet all this beauty hides a terrifying truth. One misstep, one tiny miscalculation, and nothing, not even light, can escape. This is the ultimate cosmic predator, and it doesn't just consume matter, it swallows time, space, and reality itself. Black holes are born from the death of stars. When a massive star exhausts its nuclear fuel, it can no longer support itself against the pull of gravity. The star collapses, imploding inward, and in a cataclysmic explosion known as a supernova, the outer layers are ejected into space. What remains is a core so dense, so heavy, that its gravity becomes unstoppable. A black hole is formed, a singularity wrapped in a cloak of mystery. But not all black holes are the same. There are stellar black holes formed from individual stars. There are supermassive black holes, millions or even billions of times more massive than our sun, lurking in the hearts of galaxies. And there are intermediate black holes, a middle ground that still puzzles scientists. Despite their differences, all black holes share one common feature, an event horizon. This is the point of no return. Once crossed, matter and light are pulled inexorably inward, never to escape. The event horizon is a line of ultimate danger. It is invisible, yet it marks the boundary between our known universe and a realm of unimaginable extremes. Beyond this point, physics as we know it begins to break down. Time itself is stretched, twisted, and warped. A clock falling into a black hole ticks slower and slower, approaching a standstill at the event horizon. Space bends and folds, light curves in impossible ways, and reality becomes stranger than anything we can imagine. Scientists have tried to study black holes using every tool at their disposal. Telescopes, satellites, and even gravitational wave detectors have revealed clues, but no one has ever looked inside. The singularity, the very heart of a black hole, remains one of the greatest mysteries of the universe. Some scientists believe it is a point of infinite density, where matter is crushed beyond comprehension. Others speculate that black holes could be gateways to other universes, cosmic tunnels connecting distant realms of existence. And yet, the black hole is not just a distant curiosity. Its influence can be felt across entire galaxies. Supermassive black holes shape the formation of stars and the evolution of galaxies. They regulate the flow of matter, controlling the dance of cosmic structures on a scale far beyond human comprehension. Even our own Milky Way is home to one, a sleeping giant named Sagittarius A*, weighing over 4 million times the mass of the Sun. It sits quietly at the center of our galaxy, invisible but ever-present, a reminder of the universe's power and mystery. The danger of a black hole is absolute. Its pull is relentless, its gravity unstoppable. Yet, it also inspires awe. It challenges our understanding of the universe and pushes the boundaries of science. What happens if you fall into a black hole? Will you be stretched into a thin strand torn apart by gravity? Or will you enter a realm beyond our imagination, a place where time and space are meaningless? These questions linger at the edge of human curiosity, beckoning us toward the unknown. As we move closer, the visuals of the black hole become more dramatic. The accretion disk glows fiercely, jets of plasma shoot outward at near-light speeds, and surrounding stars appear distorted, like reflections in a cosmic funhouse mirror. The very fabric of space-time twists and bends, revealing the extreme nature of gravity. Every photon of light struggles to escape, yet the black hole consumes relentlessly. The scene is both terrifying and mesmerizing, a cosmic ballet of destruction and beauty. And yet, despite all this danger, scientists are not afraid, they are curious. They study black holes using indirect evidence, the motion of stars, the behavior of nearby gas, and the subtle ripples in space-time called gravitational waves. In 2019, humanity captured the first-ever image of a black hole's shadow, a dark circle surrounded by a ring of light. It was a milestone, a glimpse into the heart of darkness, a testament to human ingenuity and curiosity. The journey to understand black holes is also a journey to understand ourselves. They force us to confront the limits of knowledge, to question the nature of reality, and to marvel at the universe's vastness. In a black hole, the familiar rules of physics no longer apply. Gravity dominates, time slows, and space itself is twisted. It is a place of extremes, a cosmic laboratory where the laws of the universe are pushed to their limits. But the black hole remains a mystery. What lies beyond the event horizon? What is the singularity truly like? Are black holes portals to other worlds, or are they the ultimate graveyards of the cosmos? These questions remain unanswered, teasing the imagination and fueling the human desire to explore. As the camera drifts away from the black hole, the universe stretches endlessly in all directions. Galaxies spin gracefully, stars blaze brilliantly, and the cosmos continues its silent dance. Yet in the distance, the black hole waits, a hidden predator, a cosmic enigma, a force beyond comprehension. It is a reminder that the universe is vast, mysterious, and far stranger than anything we can imagine. The story of black holes is not just a story of destruction. It is a story of curiosity, exploration, and wonder. It is a journey into the unknown, a quest to understand the very fabric of reality. And as we take our first steps into this mysterious realm, one thing becomes clear. Black holes are not just cosmic monsters. They are gateways to the deepest mysteries of the universe, and our journey has only just begun. The screen fades to black, leaving viewers with a sense of awe and suspense. What lies inside a black hole? Will humanity ever know? The answers remain hidden, waiting for those brave enough to seek them. And so, the journey continues. The universe is alive with motion. Stars are born, shine brilliantly, and die in spectacular explosions. Among these cosmic giants, some will end their lives not as quiet embers, but as monstrous entities, black holes. To understand the mysterious monsters that lurk in the depths of space, we must first witness their birth. This is the story of creation, destruction, and transformation on the grandest scale. Every black hole begins its life in a star, a glowing sphere of gas and fire. Stars are the engines of the cosmos, creating light, heat, and elements that form planets, life, and galaxies. They are born in clouds of gas and dust called nebulae. Gravity pulls these clouds together, and as the gas condenses, pressure and heat build. Eventually, nuclear fusion ignites in the star's core, and a star is born, a brilliant beacon in the darkness of space. Stars come in all sizes. Some are small, like our sun, shining steadily for billions of years. Others are massive, tens or even hundreds of times the mass of the sun. It is these massive stars that have the potential to end as black holes. The heavier the star, the more spectacular and terrifying its final moments. For millions of years, a massive star burns brightly, fusing hydrogen into helium in its core. This process releases enormous amounts of energy, pushing outward against the pull of gravity. A delicate balance is maintained. Fusion pushes out, gravity pulls in. But eventually the fuel runs out. Hydrogen is depleted and the star begins fusing heavier elements like helium, carbon, and oxygen. The core becomes hotter and denser. Layers of fusion build up like the rings of a cosmic onion, each stage shorter and more violent than the last. Then comes the dramatic finale, the supernova. When the core can no longer withstand the crushing gravity, it collapses in a fraction of a second. The outer layers are expelled in a titanic explosion, brighter than an entire galaxy for a brief moment. Shockwaves ripple through space, spreading newly formed elements, iron, gold, and uranium into the cosmos. These elements, forged in the heart of dying stars, become the building blocks of planets, moons, and life itself. But at the center of this explosion, something extraordinary forms. The core collapses under its own weight, compressing matter to an unimaginable density. Gravity overwhelms all other forces and a black hole is born. It is a point of no return, an object so dense that nothing, not light, not matter, can escape. There are different types of black holes, each with its own story. Stellar black holes form from individual massive stars. They may be only a few kilometers across, but their gravity is extreme. Intermediate black holes are larger, potentially formed from clusters of stars or merging black holes. Supermassive black holes, millions to billions of times the mass of the Sun, reside at the centers of galaxies. Their origins are still a mystery, though some may have formed from the collapse of giant clouds of gas in the early universe. Imagine witnessing a star's death from a safe distance. The explosion lights up the sky, a cosmic firework display. For a moment, the universe seems alive with color, energy, and motion. But at the heart of this brilliance lies a dark secret, a newborn black hole. Invisible yet exerting immense gravitational pull, it begins to shape its surroundings, influencing the motion of nearby stars and gas. Black holes do not grow quietly. They feed on anything that comes too close: gas, dust, even entire stars. As matter falls into the black hole, it forms an accretion disk, heating up and emitting powerful X-rays. Some black holes launch energetic jets of particles at near-light speed, stretching across thousands of light years. The universe itself trembles under their influence, as if acknowledging the presence of a new cosmic giant. Yet, despite their destructive power, black holes are not mere cosmic monsters. They play a crucial role in the life of galaxies. Supermassive black holes regulate star formation, influence the shape and motion of galaxies, and act as engines driving the evolution of cosmic structures. Without them, galaxies like our own Milky Way might look very different, perhaps chaotic, unstructured, or unable to form stars efficiently. The life cycle of a star and the birth of a black hole is also a story of transformation. Matter is not destroyed. It is reshaped, redistributed, and recycled. Elements forged in stars become the seeds of new stars and planets. In a sense, black holes are part of the cosmic cycle of life and death, extreme examples of nature's power to transform the universe. Scientists study black holes indirectly, using the light and matter around them. They observe stars orbiting invisible objects, measure X-ray emissions from accretion disks, and detect ripples in space-time called gravitational waves, vibrations caused by colliding black holes. These observations give clues to the formation, growth, and behavior of black holes, allowing humanity to glimpse the invisible forces shaping the cosmos. The birth of a black hole is also a story of extremes. Gravity, density, and energy reach levels that challenge our understanding of physics. In the core of a collapsing star, matter is compressed beyond imagination. The singularity, the central point of a black hole, represents a breakdown of known laws. Space and time are warped, and the familiar rules of the universe no longer apply. Yet, black holes remain enigmatic. Even after decades of study, many questions remain. How exactly do supermassive black holes form so quickly in the early universe? What is the true nature of the singularity? Could black holes be portals to other dimensions or universes? Scientists continue to theorize, simulate, and explore, driven by the same curiosity that has propelled humanity to the stars. Observing a black hole in formation is a reminder of the scale and drama of the universe. Stars live and die in patterns that span millions of years, yet the effects of their deaths ripple across space and time. A single supernova can trigger the formation of new stars, while a black hole can influence the motion of entire galaxies. It is a cosmic dance of creation and destruction, with black holes as the ultimate choreographers. Visualizing this process is awe-inspiring. Imagine a massive star collapsing, light bending around the forming black hole, jets of energy shooting into space. The accretion disk glows with intense heat, stars nearby are distorted by gravity, and cosmic debris spirals inward in a mesmerizing, chaotic ballet. Every detail, from the smallest particle to the largest jet, tells a story of power, mystery, and cosmic order. Black holes remind us of our place in the universe. They are distant, extreme, and dangerous, yet they are part of the same cosmic web that includes our sun, our planet, and life itself. Studying them expands our understanding of physics, time, and space. They push the boundaries of human knowledge, challenging scientists to explore the impossible. And so, the birth of a cosmic giant is not just a tale of death, it is a tale of beginnings. From the collapse of a massive star, a new entity emerges, shaping the cosmos and inspiring awe. Black holes are reminders that the universe is dynamic, mysterious, and far more complex than we can ever imagine. As we step back and observe from afar, we see the broader picture. Stars shine, galaxies rotate, and black holes influence the dance of the cosmos. The universe is alive with motion, energy, and change. Each black hole is a testament to the power of gravity, the extremes of physics, and the incredible cycles of creation and destruction that govern the cosmos. The story of black holes is just beginning. Each discovery leads to new questions. Every observation uncovers new mysteries. The journey to understand these cosmic giants continues, guiding humanity toward the edge of knowledge, curiosity, and wonder. In the next chapter, we will approach even closer to the edge of the black hole itself. We will explore the event horizon, the boundary where time slows, space twists, and reality as we know it begins to break down. The mysteries grow darker, the stakes higher, and the universe more surreal. At the heart of the cosmos lies a boundary that no traveler has ever crossed. It is invisible yet absolute, a threshold beyond which nothing returns. This is the event horizon, the edge of a black hole, where the rules of physics begin to unravel and the very fabric of reality twists in ways humans can barely imagine. To approach it is to face the ultimate cosmic mystery, to gaze into the unknown, and to confront the limits of our understanding. The universe from a distance seems calm. Stars shine steadily, planets orbit predictably, and galaxies spin gracefully. But as one approaches a black hole, this illusion shatters. Space itself bends, light warps, and time behaves strangely. The closer you get, the stranger the universe becomes. Here, gravity is not just a force, it is a distortion of reality, bending space and time into unimaginable shapes. The boundary that defines this extreme realm is called the event horizon. It is the invisible line around a black hole beyond which escape is impossible. Step over it and no signal, no particle, no light can ever return. It is a cosmic point of no return, threshold that defines the ultimate limits of existence. Scientists have described the experience near an event horizon using mind-bending physics. Gravity near a black hole is so intense that it stretches space and slows time. An astronaut hovering near this boundary would see the universe around them move at impossible speeds, while their own clock ticks slower and slower. This phenomenon, known as time dilation, is a direct consequence of Einstein's theory of relativity. Imagine an explorer descending toward the event horizon. Far away, observers see their motion slow, frozen in time, as if the universe itself is holding its breath. But for the explorer, time continues normally. Seconds tick by, thoughts unfold, and moments pass. The closer they get, the more extreme the effect. It is a perspective of reality that defies intuition, where one of the universe's fundamental rules, time, splits into two realities, depending on one's proximity to gravity. Gravity near the event horizon does not just affect time, it warps light. Stars appear stretched, twisted, and doubled. Galaxies behind the black hole bend around it, creating strange, surreal visual effects called gravitational lensing. Light itself curves, making distant objects appear in the wrong place, distorted by the immense gravity. The cosmos, once familiar, becomes alien, a visual spectacle both terrifying and beautiful. The event horizon is not a physical surface. There is nothing to touch, nothing to collide with. It is a boundary defined by the power of gravity, by the point at which the escape velocity exceeds the speed of light. Nothing, not even light itself, can escape once it crosses this threshold. Yet in its presence, everything changes. The universe stretches, twists, and folds. The rules that govern planets, stars, and galaxies no longer apply in the same way. As one approaches the edge, a new danger emerges: spaghettification. The gravitational pull of a black hole increases dramatically with proximity. Stretching along the direction of the pull, matter is elongated into thin, thread-like strands. An astronaut falling feet first would find their body stretched and torn by gravity, a vivid demonstration of the black hole's overwhelming power. It is a phenomenon so extreme it challenges every notion of physical integrity, a reminder of nature's unyielding force. Yet, the event horizon is also a source of cosmic wonder. Around it, the accretion disk burns brilliantly. Gas and dust spiral inward at near-light speeds, heating up to millions of degrees and emitting intense X-rays and gamma rays. Jets of particles are sometimes ejected perpendicular to the disk, stretching across thousands of light-years, illuminating distant corners of space. The black hole, invisible at its core, announces its presence through this spectacular display of energy. Scientists cannot enter a black hole to observe it directly, but they can study these energetic phenomena. By analyzing the X-rays from accretion disks, tracking the motion of stars near the black hole, and detecting gravitational waves from colliding black holes, humanity has begun to piece together the mysteries of these cosmic giants. These observations reveal not only the existence of black holes, but also their incredible influence on the surrounding universe. Approaching the event horizon is a journey into extremes. The laws of physics as we know them begin to break down. Space-time curves sharply, gravity dominates, and energy behaves unpredictably. It is a place where intuition fails, where the familiar rules of cause and effect are challenged, and where the universe displays its most extraordinary phenomena. One of the most fascinating aspects of the event horizon is the information paradox. According to quantum physics, information about matter falling into a black hole cannot be destroyed. Yet, classical physics suggests that all details of matter crossing the event horizon are lost. This paradox has puzzled scientists for decades. How can the universe reconcile these conflicting truths? Could black holes store information in ways we do not yet understand, perhaps on the very surface of the event horizon itself? These questions push the boundaries of science, theory, and imagination. Visualizing the event horizon is both terrifying and mesmerizing. Imagine a glowing disk of matter, spiraling inward at impossible speed, warping light around it. The black hole at the center is invisible, a shadow so profound it absorbs everything, bending the fabric of space-time itself. Surrounding stars appear stretched and doubled, galaxies curve around the invisible abyss, and the cosmos becomes a hall of mirrors reflecting the power of gravity. Time near the event horizon is a river running backward in perception. For an outside observer, a falling object seems frozen in motion, hovering at the edge of the abyss. But for the object itself, seconds pass normally, its journey inexorable. This strange duality is a window into the mind-bending nature of black holes, a place where reality itself is relative, shaped by gravity in ways that challenge our understanding. Despite the danger, black holes are not simply destructive. They are also engines of creation and transformation. The energy emitted by accretion disks can trigger star formation in nearby clouds of gas. Supermassive black holes can influence the structure of entire galaxies, regulating the birth and death of stars. Even in their darkness, black holes shape the universe, orchestrating cosmic events on scales far beyond human comprehension. Yet the singularity at the heart of a black hole remains inaccessible. A point of infinite density, it defies the laws of physics. Space and time collapse, and the known rules of reality cease to exist. Scientists can only theorize what happens beyond the event horizon. Some suggest wormholes or alternate universes. Others propose that the singularity is a bridge to dimensions beyond our own. Whatever the truth, it remains one of the greatest mysteries of the cosmos. The edge of the unknown is both awe-inspiring and humbling. Standing at a safe distance, one can witness the interplay of gravity, light, and time on a scale unlike anything on Earth. The black hole dominates its surroundings, invisible yet omnipresent, warping space, stretching time, and influencing matter across vast distances. Every star, every photon, every particle feels its presence, shaping the cosmos in subtle but profound ways. For humanity, approaching the event horizon is more than a scientific endeavor. It is a journey into the limits of knowledge. It is a quest to understand the universe at its most extreme, to confront questions that challenge our understanding of reality, and to marvel at the incredible power of nature. The edge of a black hole is not just a boundary in space. It is a boundary in human understanding, a threshold where curiosity meets the unknown. As the camera drifts away, leaving the event horizon behind, the universe stretches endlessly. Stars burn, galaxies spin, and the black hole continues its silent, inexorable influence. The edge of the unknown is both a warning and an invitation. It reminds us that the cosmos is vast, mysterious, and far stranger than our minds can imagine. The story of the black hole continues beyond the event horizon. In the next chapter, we will venture into the realm of theories inside the singularity, exploring the mysterious heart of the black hole. What exists where physics breaks down? Are there hidden universes, exotic particles, or phenomena that defy imagination? The mysteries grow deeper, and the universe darker. As we journey further into the cosmic abyss beyond the event horizon lies a realm that no human has ever seen, a place where the known laws of physics crumble and the universe itself seems to twist into unimaginable shapes. This is the singularity, the heart of the black hole, a point of infinite density and mystery. To journey inside is to enter the unknown, a region where time, space, and matter behave in ways that defy all expectation. The singularity is the ultimate paradox of the cosmos. On the outside, we see a black hole as a dark void surrounded by glowing gas and dust, a cosmic predator devouring everything near it. But on the inside, physics as we know it ceases to exist. Matter is crushed beyond comprehension. Gravity becomes infinite. Space and time fold in on themselves, creating a region that is utterly alien, yet central to the structure of the universe. No telescope, no probe, and no human mind has directly observed the singularity. It exists only in the equations of Einstein's general relativity and the predictions of modern astrophysics. These equations suggest that at the core of every black hole, all the mass that once occupied a star is compressed into a point with zero volume but infinite density. It is a concept so extreme that it challenges our understanding of reality itself. Yet, scientists have theorized what might exist there. Some propose that the singularity is not a simple point, but a gateway, a passage to another dimension or even another universe. The idea is rooted in the mathematics of space-time. According to some solutions of Einstein's equations, black holes could connect distant regions of space-time through tunnels called wormholes. These hypothetical shortcuts could, in theory, allow matter or information to travel across vast cosmic distances, or perhaps even to entirely new universes. The concept of a wormhole sparks both awe and skepticism. On one hand, it tantalizes the imagination. Could a black hole be a doorway to an entirely new cosmos, hidden beyond the veil of the singularity? On the other hand, the forces inside a black hole are so extreme that any object attempting to pass through would likely be torn apart by tidal forces. Yet the possibility alone drives scientists to explore, simulate, and theorize. Wormholes remain a bridge between scientific possibility and cosmic wonder. Another fascinating phenomenon associated with black holes is Hawking radiation, proposed by physicist Stephen Hawking in 1974. Contrary to their reputation as cosmic vacuum cleaners, black holes are not entirely black. Quantum effects near the event horizon allow them to emit tiny amounts of radiation, slowly losing mass over billions of years. In theory, a black hole could eventually evaporate completely, leaving behind a faint echo of its existence. Hawking radiation challenges our understanding of the universe. It suggests that black holes are not entirely destructive. They can emit energy, influence their surroundings, and even die. This discovery bridges the realms of quantum mechanics and general relativity, two of the most fundamental pillars of physics. It raises profound questions. What happens to the information about matter that falls into a black hole? Can it truly be destroyed, or is it encoded in some subtle, invisible form? The information paradox is one of the most intriguing puzzles in modern astrophysics. According to quantum theory, information cannot be destroyed. Yet, if matter falls into a black hole and the black hole eventually evaporates, does that information disappear forever? Some scientists suggest that information is preserved at the event horizon, stored holographically in the patterns of energy and radiation, a concept known as the holographic principle. Others propose that black holes may connect to parallel universes, where the information continues to exist in a different form. The singularity may also harbor even stranger possibilities. Some theoretical physicists speculate that inside black holes, exotic forms of matter and energy could exist, conditions so extreme that new physical laws might emerge. Space could be infinitely curved, time could loop upon itself, and dimensions beyond our perception might unfold. In this hidden realm, the universe becomes a laboratory of extremes, testing the limits of imagination and scientific theory. Visualizing the singularity is nearly impossible, yet simulations offer glimpses into its power. Imagine a point where all matter is compressed into a single, dense speck, gravity so intense that it bends light and warps space-time. Surrounding it, the accretion disk blazes with intense heat, matter spiraling inward at near-light speed. The event horizon glows, not with matter escaping, but with the energy and tension of the unknown. It is both terrifying and mesmerizing, a cosmic paradox of destruction and beauty. Black holes also challenge our understanding of time itself. Near the singularity, time as we know it may cease to exist. Seconds, minutes, and hours lose their meaning. The future and the past may merge into a singular moment, a cosmic instant beyond comprehension. This extreme warping of space-time forces us to reconsider our assumptions about reality. What does it mean to exist where time no longer flows? How can the universe continue if time is distorted beyond recognition? Despite the dangers, black holes inspire exploration. Humanity has never sent a probe inside a black hole and perhaps never will. But through observation, simulation, and mathematics, we can study their effects, model their behavior, and imagine the mysteries hidden within. Black holes are not just objects of fear, they are catalysts for discovery, challenging scientists to think beyond the ordinary, to question reality, and to push the boundaries of knowledge. The singularity also raises philosophical questions. If a black hole can store or transport information, if it can warp time and space, Does it represent a kind of cosmic consciousness? Are black holes simply extreme physical objects, or do they hold the keys to deeper truths about the universe? These questions blur the line between science and philosophy, merging curiosity, imagination, and wonder. As we explore further, the black hole becomes a stage for cosmic drama. Jets of matter burst outward, illuminating distant regions of space. Stars nearby are torn apart, their remnants feeding the growing singularity. Galaxies feel its pull, slowly influenced by its mass and gravity. It is a reminder that even in the darkness, black holes shape the cosmos, orchestrating events on scales beyond comprehension. The journey inside a black hole is ultimately a journey of the mind. It forces us to confront the limits of our understanding, to imagine conditions far beyond human experience, and to wonder about the ultimate fate of matter, energy, and information. Each theory, from wormholes to Hawking radiation, opens a door into possibilities that stretch the imagination and challenge scientific thought. Some scientists even speculate that black holes could be the seeds of new universes. When matter collapses into a singularity, the energy and density might trigger a bounce, creating a new cosmos entirely separate from our own. In this view, black holes are not merely endpoints, they are beginnings, cosmic wombs giving rise to new realms of space and time. Yet for all these theories, one truth remains: no one knows for sure. The singularity remains inaccessible, the interior of a black hole a realm of pure mystery. Our understanding is limited to mathematics, simulations, and indirect observations, and perhaps that is fitting. Black holes are, after all, the ultimate guardians of cosmic secrets, challenging humanity to explore, imagine, and wonder. As the camera retreats from the singularity,